Okay. Well, Carol, um, I was making up this slideshow at one point, trying to review people for the test, and I did something different here. But here, in terms of graphing the functions, I'm not quite sure what you mean by I have no idea where to start. So that gives me no idea where to start, but this is where I'm going to start. First thing you need to do is commit to memory a series of functions called the library of functions. And I believe there's like 4 of them that's worth committing to memory. Later on in our work in this next test, there'll be 2 more added to it, but they're pretty simple. The first one is absolute value of x. And realize it's basically a 45-degree line going in either direction from 0, 0. That needs to be committed to memory. Second one is the parabola y equals x squared. Again, the vertex of that parabola down at 0, 0 for this original. The third is y equal the square root of x. It's like taking that parabola, knocking it on its side, but it's really only 1/2 of the parabola that's sitting on its side, is the function y equals square root of x. And finally, y equals x cubed is sort of this, what we sometimes call the sigmoidal shape. It starts like a parabola opening upward, and then it turns into a parabola opening downward, or vice versa, depending on how you phrase it. But it's this shape right here. So f of x equals x cubed is the fourth thing you want to commit to memorizing. Okay, now the next slide here, I didn't label the top of it, is what happens when you add or subtract something to or from the output of the function. Okay, so we've got absolute value of x being graphed down here in blue. What happens when you describe f of x plus 3? That ends up raising the graph by 3 units. And it doesn't just work that way for absolute value, it works that way for any function. If f of x is in one location, then the graph of f of x plus 3 just takes all those points in f of x and slides them up 3 units. F of x minus 4 just takes all these points in y equals f of x and slides them down 4 units. So this is adding to the output of a function. If you're adding to the input of a function, that slides the graph from left to right. And it does it in probably the way opposite you might think at first. So again, in blue is the graph of y equals f of x. In this case, f of x being equal to the absolute value of x. What does adding 3? Notice this plus 3 is inside the absolute values. So this is, let me just see the pointer option, get my pen option. This is f of x plus 3 we're talking about, not f of x and then add 3 afterwards, right? So this down here is f of x plus 3. Well, adding 3 to the input slides it actually back 3 units. Slides it 3 units in the negative direction, whereas putting -4, adding -4, subtracting 4 from the input, slides it 4 units in the positive direction. So adding to the output of a function, that is something like f of x plus 3, that slides the function up or down, and it slides it in the direction you'd think it would. Adding inside, that is to the input of a function, slides it left to right, and slides it in the opposite direction you think it would. Okay, so that's translations, and that's all I have on those slides. We will talk a little bit more in the next video about multiplying the input and output of a function by something. That's actually what I talked about on those videos in the announcements.